Hi, this is Evans from Crazy Chemistry, and today we're going to speak about terbium. Imagine traffic lights without green, only red, maybe yellow, car stops, it never moves, traffic builds up, everyone is trapped. All of this because one element is missing terbium. This episode, we're going to see together why terbium is used for green light in displays, how it produces very sharp green light, and why it is also used in advanced magnetic materials. Terbium is element number 65 in the periodic table, a silvery metal from the lanthanide series. Its atomic mass is 159 U, its atomic radius is 177 picometers, and its melting point is 1356 degrees Celsius. Like other rare earth elements, terbium is found embedded in minerals and rocks such as bastnasite and monazite, and it can be mined in China, US, and Australia. Its most common oxide form is this one, and its electron configuration looks like this. It typically forms terbium 3 plus ions like the rest of the lanthanides with an electron configuration that looks like this. Just like europium, terbium can produce light, and not just any light, very pure and intense color green light, which happens through a process which is called luminescence, how we explain it in the europium video. When energy is applied to the atom through electricity or radiation, this energy is absorbed by the electrons of the atom that they get excited and they get elevated in a higher energy state. This state is more unstable, the electrons cannot stay there for long, and when they drop, they release the extra energy in the form of a photon with a specific frequency. In the terbium atom, these transitions take place inside the orbital, and they're considered as 4f to 4f transitions. Because the 4f orbital is buried inside the atom, these transitions are not interrupted by a neighboring atom. And that is why terbium produces very intense green color. This green emission typically appears at 540 nanometers, right in the region that the human eye is the most sensitive, which makes terbium extremely efficient for displays. Displays don't just need red, green, and blue, they need the right green, and terbium provides one of the purest green lights. This matters because the human eye is more sensitive to green light. Our eyes evolved to detect wavelengths around 540 nanometers more efficiently than any other color. That means that small improvements in green have a huge impact on how we perceive the entire image. If the green is weak or inaccurate, the whole image looks dull and unnatural. But when the green is pure and precise, everything looks brighter, sharper, and more realistic. So terbium doesn't just add color. It improves how we see the entire display. Humans evolved in environments dominated by plants, forest, and vegetation. Plants reflect light strongly in the green region, 500 to 570 nanometers. During human evolution, our eyes develop three types of cone cells. S cones, which are responsible for blue, around 420 nanometers. M cones, responsible for green color, 534 nanometers. And L cones, which are responsible for the red light, at 564 nanometers. But here is the key. We have more green sensitive cones than blue ones, and the response is stronger and more efficient. The human eye is not equally sensitive to all colors. It is tuned to green. It is used in LED screens, TV displays, and in fluorescent lighting. Terbium has another important role. It is used as a magnetic material. When it's added to alloys, terbium can improve their magnetic performance, especially when it is combined with iron and rare earth magnets. It can create materials that respond very strongly to magnetic field and find important applications in magnetostrictive materials. These are materials that can change shape when they're placed inside the magnetic field. Terbium alloys can expand or contract when they get magnetized. This is a property that is used in actuators, sensors, and precision control systems. Sonar can be a real-world example where the tiny motions can create vibrations, and these vibrations become sound. And this is how ships detect objects underwater. So terbium doesn't only produce light, but it also converts magnetic energy into mechanical motion. Terbium behaves also like the rest of the lanthanides. It forms terbium 3 plus ions, but unlike europium, it does not strongly favor the plus 2 state. This means that it's more stable chemically. In terms of price, terbium oxide is relatively expensive, ranging between $500 to $1,500 per kilogram. This is because it's less abundant and is required for high performance materials. Every time you look at a bright, vivid screen with strong, balanced colors, you are seeing the results of terbium. So the next time that your screen lights up, remember what gives it life: terbium. So that's it for today. Thank you for watching the video. If you like the video, please consider liking, subscribing, and sharing it. If you like, leave a comment as well. I'll see you next time. Bye.